All right, this will be 34 through 39. 34 says describe the atom in your own words, so obviously my words are useless. So you can do number 34 on your own. So let's look at 35 through 39. This used to be so much easier when you guys had already had physics. So I'll have to give you a short, very short physics lesson. I already did a little bit in class, but let's just talk. The electromagnetic spectrum measures energy of electromagnetic radiation through a, wow, how do I put this? It's been 5 years since I taught physics. But it lines them up according to their frequency, energy, and wavelength. All right, in the middle of the electromagnetic spectrum, you'll see visible light. You can see that right here. It's pointing to this area. That's our visible light. And then it gives you the colors. I don't really like this. I wish it was written differently because it's backwards. I mean, it's still true, but it's the big Guri instead of Roy G. Biv. It's just showing you from high to low instead of low to high. So gamma, if we look right here, gamma radiation is high energy, short wavelength, high frequency. Then at the other end we have radio, low energy, low wavelength, low frequency. All right, so this table is giving me or showing me the relationship between energy, wavelength, that's a funny symbol for that, it's called lambda, and frequency. That's how it's showing me the electromagnetic spectrum, the relationship between the two. You'll notice that as the energy gets lower, we get longer wavelength and lower frequency. Or as the energy gets higher, we get shorter wavelength and higher frequency. All right, 35. Electromagnetic spectrum shows the relationship between. All right, you just have to read through those options and find out which one I just told you. I won't insult your intelligence by helping you anymore. All right, 36. Which of the following occurs as energy of the electromagnetic radiation increases? All right, let's look where the high energy is. That's on the left, right there. So as I go this direction, what happens? I just love drawing arrows. All right, so we would say, all right, do I get an increase in wavelength? That would be no, because I get shorter. All right, do I get a wavelength decrease? Oh, that's correct. But look how mean I am. E says both B and C are correct. So let's check C. Frequency increases. Oh, hey, high frequency. So that's also true. So not just B and C are correct, but E, which says B and C are correct. All right, you just have to look at how these relate to each other. Oh, I didn't think I was drawing right there. That's cool. How did I even do that? Yeah, I can draw through my finger. That is fun. You don't really care. But anyway, all right, I want to look at 38 though. 38 is an awesome question. When an excited electron drops from the fourth, so I'm just going to draw little lines here like rungs on a ladder. All right, so here's the fourth. When an electron drops from the fourth to the second, so here's 1, 2, 3, and the fourth, a photon that exhibits the color green. Sorry, I don't have green on this marker, but pretend it's green. What would the color be of a photon emitted when an electron drops from the third to the second? All right, so have a smaller drop. So a smaller drop should give off light with, hopefully you know, less energy, which would mean long wavelengths and low frequency. Excuse me. All right, now it says, what color would it be? Well, if this was green, I want you to use this information to tell me what would it be, and then at 39 explain why your choice is correct. All right, the answer better not be green. I'll leave the rest to you. All right, these are awesome questions. Give them a chance.